For my children, oh, I should probably put this. Okay, yesterday we were on implicit differentiation. We're going to spend a little time here first, and then we're going to go into our last section. And my anticipation is the last section will take a day and a half to 2 days to do. So we're looking at the test because Vicki asked me so kindly. We're looking at the test probably Wednesday or Thursday of next week. So Wednesday or Thursday of next week. We'll see what happens. We'll see what I actually don't have a problem pushing it back to Friday, provided, of course, we start going into new material after we finish 3.9. I don't care. If you all want to push it back to next Friday, cool, but I will start chapter 4. You make the decision. I'm not going to ask you right now. No, it won't. Chapter 4 will just be on the chapter 4. I just have to introduce new material anyways. So I won't put chapter 4 on this test because it's only chapter 3. So I really don't care how you decide to do it. You can tell me by next week. I know you all talk to each other. So make the decision by next week whether you want it on Friday or Thursday of next week. I will start new material. It will not be on this test. It will be on the next one though. Because we are behind, so I have to introduce new material. So I can't use any days as a review. So I don't care. I don't care if you all want to push the test back. You can have all the tests all at once if you want. I don't care. Not advised. But you could do that too if you all wanted to. Did we do this one yet? See, I think we did, didn't we? No. Look on your notes. Yep, I thought we did. Okay, so which one of these two would you all like to do? E? Okay, you all do E. So as we're taking a look at E, option A is we write this left-hand side as 3x to the 7th plus y squared raised to the 1/2. That's one way of doing it. What's the other way of doing this? Squaring both sides. That's the other way of doing this. So if you don't want to work with a square root, which will make it a little bit more interesting to get rid of your dy dx, then you square both sides. So however you want to do it, it doesn't matter. So if you decide to do it this way, then you will just go ahead and do the derivative implicitly. I would recommend, however, to square both sides. It's really up to you what you choose to do, but the squaring both sides is going to make your life a tad bit easier. I'm just going to erase this bottom part because I don't really want it here. So I'm going to just get rid of this. All right, so I'm going to go ahead and square both sides, and then on the left-hand side, I just get 3x to the 7th plus y squared. All right? On the right-hand side, this is a perfect square trinomial, so I'm going to use that information. What I'm talking about when I say a perfect square trinomial is if I have a plus b squared, this is equal to a squared plus 2ab plus b squared. So I'm going to use that information to expand that out correctly. And so I'm going to end up with sine to the 4th y, because that is my sine squared squared, plus 2 times 100, so that's 200, xy sine squared y, and then plus, and then it's going to be 100 squared, so I'm just going to write it as 100 squared because I don't want to write a bunch of zeros, x squared y squared. How are we doing? Now we're going to do this implicitly. So I'm just going to start doing the derivative starting on the left-hand side. Every time I see a y, I treat it as if it is an x. The rules that we have in terms of our derivatives are still going to hold true. But remember, I'm doing it with respect to x, so that means I have to add on a dy dx. So 3 times 7 is 21 x to the 6th. So that power multiplied by the coefficient, drop in a power. And then plus, I'm going to have 2y. So I bring that 2 down, the power down, multiply by 1. But it is respect to x, so it is dy dx needs to be attached to that y. Okay? On the other side, I want to think of this as sine y raised to the 4th power, so I can use the chain rule on it. So it will be 4 sine cubed y by using the chain rule. And then I'm going to take the derivative of sine y, which is cosine y. And then I'm going to do the derivative of y, which is dy dx. How was that so far? We're not done. Questions? I'm going to put this on pause. So yes, and I have it there. It just doesn't look like it. So the question is, when I did the sine, I'm going to do this in red down here. When I did the sine for y, this is the same thing as a sine y to the fourth, right? So when I do the derivative of this, so dy, the sine y to the fourth power is going to be 4 the sine y to the third power. And then it's going to be the derivative of my inner function, which is the cosine of y, and then the derivative of my angle, which is dy dx. So this is the derivative d dx of the sine y. And then this is the derivative of my angle. So those are all the pieces that happened.
So it's just exponent, inner function, and
Yeah. And then I wrote it as sine cubed instead of sine y cubed. You can write it however you want, though. It doesn't matter how you write it. Any other questions before we keep moving on? All right. This is so glorious. It is glorious. This is like the best ever. The only thing that can make this better is if we would have been doing it at 7 o'clock this morning.
Oh.
I wouldn't be awake.
Okay, so I have on my middle term there a whole bunch of stuff going on. I have 100 multiplied by x multiplied by y multiplied by sine squared y. I have a whole bunch going on. So I'm going to do the derivative of x first. What is the derivative of x? It's just going to be 1, right? Derivative of x is just 1. So 200 y sine squared y. This is the derivative of x multiplied by the other things that are going on. Okay? I'm doing the product rule here. Then I'm going to do the derivative of y. So plus 200. X is now there because I'm now doing the derivative of y. What is the derivative of y? Dy dx. And then I still have the sine squared y. So I'm doing the product rule by doing the derivative of each one of those terms, multiplying by what I'm not taking the derivative of. So this is my derivative of y. Okay? The last one I have to do the derivative on is the sine squared y. So plus 200 x and y, because I've already done the derivatives of those two individually. Now I'm going to do the derivative with the chain rule of sine squared y. So it'll be 2 the sine y to the 1 power, because I dropped a power, multiplied out. Now I'm going to do the derivative of sine, which is cosine. And then I'm going to do the derivative of y, dy dx. All of this is the derivative of sine squared y. We're not done yet. The previous piece is I was doing the derivative with respect to y, so I was doing the middle factor. This one was 1, I was doing the first factor, which was x. So all of this that I just did, all 3 of these pieces, is just the derivative with respect to x of 200 xy sine squared y. All 3 of those pieces is just that. We're not done yet.
Okay.
The fun and joy does not end here.
Do tears start somewhere?
The tears will be later.
Oh, okay.
Tears of joy, that is.
Not yet.
Tears of joy. Plus. Now, I have to do 100 squared, x squared, y squared derivative. I've got to get comfortable. This is hard work. I'm getting sweaty. Okay. The next part I'm going to do here is I'm going to do the derivative with respect to x of 100 squared x squared y squared. Okay, so that is the next piece I'm going to be doing by the product rule implicitly. So plus 100 squared 2x y squared. This is the derivative with respect to x of x squared. Yes, I'm not done yet.
But couldn't we just pull the 100 away from this to work?
Yeah, I'm not going to yet. All right, keep moving. And then plus 100 squared x squared. And what do you think I'm going to write now? 2y dy dx. And I don't care if you use y prime. I don't, because I lose it. I forget my primes and they look weird. And this is the derivative with respect to x of y squared. So these two terms are the derivative with respect to x of 100 squared x squared y squared. Are we cool? All right. So this is where the fun begins. See how small I have to make this thing? Look at that. I don't know if I'm going to be able to read this. Woo! Okay, so I need to get rid of some stuff down here because I need to bring everything to one side. Oh, I didn't mean to do that. I didn't want to erase that. So I'm going to erase this. Not well, obviously. All right, so what I need to do now is anything that has a dy attached to it needs to go to one side of the equal sign, and anything without a dy needs to go to the other side. So I'm going to come through here and I'm going to underline everything that's going to go to the left. So this one goes to the left, it's already there. This one goes to the left, so I do need to move it. This one will need to, that term needs to go to the left because it has a dy attached to it. So does this one, and so does this one. Everything I underlined will go to the left side. Everything I did not underline will go to the right side. And at the same time, I'm going to write dy dx out front because I don't want to write this more than once. I don't. Somebody said to me in my pre-calc, I think it was pre-calc 1 class, and they said, did you realize this problem took a page? I said, do you realize what's going to happen in calculus? You're going to have to get like legal size paper and start writing it like this. You know, trees are going to die for this. Okay, so I'm going to have dy dx out front. And that's just because I know I'm going to have to divide everything by it. Okay, so my first term is 2y. And that comes from this right here. Okay, now I'm going to move this one over. So then it's going to be minus, I'm going to factor out the dy, minus 4, the sine cubed y, cosine y. And takes care of that one. Then it's going to be minus, I'm going to do this next one, so minus 200 x sine squared y. And then it's going to be minus this one, which is minus 200 xy. Oh, and there's a 2 there, isn't there? So that's 400. 400 xy sine y cosine y. And then my next one is going to be minus 2 multiplied by 100 squared. I'm still not going to write that out. X squared y. Those were all the terms that had dy dx attached to them. Okay? Now, I'm going to go back through and pick up all the terms that did not have an x squared, y squared, or dy dx attached to them. So that is this one. This term will need to move to the other side of the equal sign, so it'll become minus 21x to the 6th. The other terms that don't have a dy dx attached to them is this one right here, which is the 200 y sine squared y. The next one that does not have a dy dx attached to it is this one. So it's going to be 100 squared times 2x y squared. All right, yes.
Does it matter which sign you put them all else?
No. The question was, does it matter which way I brought my dy dx's? No, it doesn't matter. Go left, go right, it doesn't matter. Your final answer is going to be dy dx is equal to this thing divided by this thing. I'm not writing it.
We have to.
You all have to. I'm not writing it.
Can we just have one side of the equal sign and just say equals A, and then the other side equal B, and just
No.
write A over B?
You think you're going to be able to do that in web work? No.
But will I be able to do it on the exam?
No.
Okay.
Okay, this is the last bit, and by the way, once we learn logarithmic differentiation, your life will be sweet compared to this.
This is pretty no. Yeah, you go back.
Yep.
Okay, that's fine.
Okay, I'm just gonna. All right, so let's move on with this deliciousness because it just gets better and better. Now, these are what you're gonna see possibly on the test, definitely on the homework, is they're asking you to find the equation of the line tangent to this particular curve. Now notice on implicit differentiation they give you both the x and the y. Give you both the x and the y. So I'm going to do b. I mean I could do c if you all want me to, but I'm going to do b. And so I'm going to do the derivative of this. So I'm going to start with the left-hand side, and I get the derivative of x cubed is going to be 3x squared. The derivative of y cubed is going to be 3y squared dy dx. How are we doing so far? Cool? This is a perfectly legitimate question to put on the test because it won't take long, not compared to the first one that took half the class. So,
Thank God.
so now I'm going to do the product rule on the left-hand side. The derivative of x is just 1, so it is 2 times 1 times y. The derivative of y is going to be dy, so 2x dy dx. How is that so far? Now, option A is you work hard. Option B is you don't. What do you all want to do?
Work hard.
We want to work hard. No, we don't. So we are solving for dy dx, but I'm not going to solve for dy dx until I start plugging numbers in. Because dy dx is the slope, the equation of the slope, right? But I have a point to put in there. So I have an x value. Wherever I see x, I can put 1 in. Wherever I see y, I can put 1 in. And then what I end up with is just looking for dy dx without all the algebra in there. It's still there, but it's not x's and y's. So because I'm given the point 1, 1, wherever I see x, I'm going to replace it with 1. So this is going to be 3, 1 squared. That's my y, or my x value. And then plus 3 y squared, which is just 1 squared, dy dx, is equal to 2 times my y plus 2 times my x. I don't know what that's all about. Close that. Times my x dy dx. So what I really have now, which makes it so much easier to see, is I really have 3 plus 3 dy dx is equal to 2 plus 2 dy dx. See how much easier that is to look at?
So you move them over once you plugged in one.
Yeah, so now I'm going to solve for dy dx after I've put the numbers in. It makes it easier to solve for, because this is something we are familiar with. We learn how to solve for a variable when I see a lot of numbers in a single variable much, much easier. We learn it much earlier than when we're solving for a variable and we have a bunch of other variables involved. So now, anything that has a dy dx, which way you want to go, left or right?
Left.
Let's go left. So I'm going to subtract 2 dy dx, so I just get dy dx. And then I'm going to subtract 3 from both sides, and I just get -1. That's the slope of the tangent. So if I'm asked to find the equation, then all I have to do is use this form. Y is equal to slope x minus x1 plus y1. What was my slope? -1. Y equals -1, x minus 1 plus 1. Isn't that sweet? So it's not bad. Once we can start plugging numbers in, it's not too bad. So we get y is equal to -x plus 2. And there's my equation of the tangent at that point. I'll give you a moment to look.
Remember this before you make
All right.
Can you go back for like 1 more second? Thank you.
For the second derivatives, woo, of course we are.
If I say we're not, are we going to take the rest off and
Okay. So the first thing I need to do is do the derivative implicitly. Which one do you want me to do? B as in boy? Okay. So I'm going to do the derivative initially. I'm going to do the implicitly. And so I'm going to get the derivative of 4x is 4x cubed. The derivative of y to the fourth is 4y cubed dy dx. Derivative of 64 is 0. So now I'm going to solve for dy dx. So dy dx is equal to -4 over 3 x cubed. So all I did was move that to the other side. And then I'm going to divide by the 4y cubed. So this is equal to dy dx is equal to just y cubed, or x cubed y to the -3. I'm going to write it like that because I don't want to do the quotient rule. And there's a negative attached to the front. Okay, how are we doing? Okay, now I have to do the second derivative. So this is what I'm doing now, is I'm doing d dx of dy dx, and I'm doing the derivative with respect to x of the -x to the third y to the -3. So I'm doing the second derivative. The left-hand side is pretty straightforward. The left-hand side is just going to be d2y dx2. That's just indicating the second derivative. The right-hand side is just going to be -3x squared y to the -3. So I did the derivative of x cubed first. Plus, now I'm going to do the derivative of -3, and it'll be a plus because it'll be a -3 times a -1 out front, so it will be a plus. 3x squared, or x cubed, y to the -4 dy dx. How is that so far? And I'm not done. Is that cool? What is dy dx, however? Was that, oh, that was delicious? Cool. Let's keep moving then. So this is equal to negative 3x squared y to the negative 3 plus 3x cubed y to the negative 4 multiplied by negative x to the third y to the negative 3. Because that's what that's what dy dx is. I had that. She gave me this look like, are you effing kidding me? And no, I'm not factoring kidding you. So my final answer is negative 3x squared y to the negative 3 minus, because I have a positive 3 times a negative 1, so it is minus. I'm going to add exponent, so it's going to be x to the 6th. And then I have y to the negative 7. So negative 3, oh, that should be a negative 3 there. Squeeze that negative 3 in. The positive 3 times that negative 1 is a negative 3x to the 6th y to the 7th. Negative 7. So there, oh, that didn't take me that long. Cool. That means you all can do that first one. That's so delicious. Look at that. I'm going to leave that there. I want you all to do the first one. Please. All right. So let's go ahead and do this one through. So I'm going to do the derivative of the left-hand side. When I do the derivative of the left-hand side, what do you all get? Tell me what you get.
4x plus 2y.
So 4x plus 2y dy dx is equal to 0. Do you all agree to that?
Yeah.
Let's solve for dy dx. What do you get when you solve for dy dx?
2x negative 1.
How is that? Do you all agree, disagree? Just making shit up? We do that too. Let's do the second derivative. When we do the second derivative, it is d2y dx2. What do you get with the second derivative before the cleanup? Negative 2y to the negative 1. Then what?
Minus 2x times, oh wait, no. Sorry, positive 2x to
Y to the negative 2?
yeah.
dy dx?
Yeah.
But what is dy dx?
Negative x, 2x,
xy to the negative 2. And it was, you told me it was negative 2xy to the negative 1? So this is negative 2y to the negative 1 minus 4x squared y to the negative 3. Is that what you all get? No? Yes? Maybe? It's not that bad. One of these will be on the test. Not that bad. Only one of these will be on the test. Okay, more stuff on the curve. Normal lines. Oh, we need to talk about normal lines.
Anything normal in calculus?
Everything's normal and delicious in calculus. We're not done. Don't be packing up. I got 5 minutes of your time. You need your money's worth. What are you thinking? Okay. So if I'm asking for a normal line, it is perpendicular. Normal lines are perpendicular to tangents. And if you take linear algebra, this is terribly important, that normal lines are perpendicular to tangents. So here's the gist of it. You find the tangent line, and what we know about perpendicular lines, if I have the slope of 1, I multiply it by the slope of 2, this had better be negative 1. So if I tell you my slope of 1 is, say, 1/3, then the slope of my normal should be a negative 3. They are negative reciprocals of each other. So all you have to do is find the equation of the tangent slope and do the negative reciprocal of that. So let's do one of these. Let's do A fairly quickly. What I mean by fairly quickly, we have 4x to the third plus or equals 4x, and then plus 4y dy dx. Okay? So I am not going to put and solve for dy dx. I'm going to start putting my numbers in right now. I'm going to put my numbers in right now. So this is going to equal 4 times 2 cubed, because that's my x right here. and then equals 4 times 2 plus 4 times 2, that's my y, dy dx. So 2 cubed is 8, right? So 32 is equal to 8 plus 8 dy dx. So I subtract 8 from both sides. When I subtract 8 from both sides, what do I get? 24? 8 dy dx. Divide both sides by 8, what do I get? So 3 is the slope of the tangent line. So what is the slope of my normal? So the slope of my normal is equal to negative 1/3. That's it. That's it. So now all I have to do is find the equation. So y equals negative 1/3 still has to go through that point. So it'll be x minus 2 plus 2, and you just clean that up, and that's it. So normal lines are not that bad. You just find the slope of the tangent and do the reciprocal, the negative reciprocal of it. And that's it. And I'm still got 2 more minutes. Look at that. Get your money's worth. Look, just soak that deliciousness in for the next 2 minutes, because you have 2 more minutes before class is over. So, okay, so on Tuesday, this is what's going to happen on Tuesday. Tuesday and Wednesday of next week, we will do 3.9. It'll take us 2 days to complete 3.9, which is derivatives of exponentials and logarithmic functions. It'll take us 2 days. And logarithmic differentiation. If you all want the test on Friday, I don't care, but on Thursday I will start chapter 4. It will not be on the test, but I will start chapter 4. So I'm okay with that if that's what you all want to do. If you're like, I don't want to worry about that, then I will have the test on Thursday. You all need to make the decision. Sometime today, I'm going to post your quiz for this weekend, which, are you ready for this? It's just derivatives. You're going to have like 10 or 15 derivatives that you have to just find derivatives and clean up algebraically, which will be due the day of the test, whatever that day is. All right? Have a great weekend. And again, I have a study group between 1 and 4 today down in 101 in this building, which is down in the left corner down here.